Okay, this is our first lecture on Petroleum Simulation Tools, PGG451. Today I'll be introducing you to Petroleum Reservoir Simulators. Now, what comes to mind when we say simulation tools? I don't know what that does for you, but the first thing that comes to my mind is a flight simulator. And a flight simulator is like a game like terminal, which gives one the experience of flying without actually boarding a physical plane. At the terminal, turbulence could be simulated, and you have this ambience of being on the plane without actually boarding it. A trainee pilot can learn to fly it and even get competent at it. Interestingly, for all field training, we have simulators like that. The most prominent one is the well control simulator. The candidate for the IWCF well control certification is has to control a simulated large gas kick, for example, and he's expected to apply either shots, soft shotting or hard shotting to bring the well under control. However, reservoir simulators don't quite work this way because we don't have the luxury of launching through the reservoir or driving through the reservoir. Nobody actually goes down to the reservoir thousands of feet below the ground. So what is reservoir simulation? In loose terms, reservoir simulation is the art of combining physics, mathematics, reservoir engineering, and computer programming to develop a tool for predicting hydrocarbon reservoir performance under various operating strategies. Could be primary recovery, water flooding, enhanced soil recovery, and the likes. Now, more succinctly defined, reservoir simulation is the means by which a numerical model of the geologic, geophysical, and geophysical characteristics of a hydrocarbon reservoir is used to analyze and predict fluid behavior in a reservoir over time. So the main purpose of reservoir simulation is to provide an information database that can help producing company gain understanding of the rock and fluid behavior, quantify uncertainty, compare scenarios, aid in locating wells, optimizing surface and downhole facilities, all for under different recovery processes. And of course, it would help the reservoir engineer to select suitable recovery processes for that system. This schematic gives a typical workflow for reservoir modeling and simulation. And clearly from the previous definition, you see that a geological model comes into play. Now, if you start from the top left, you have geological and geophysical modeling, reservoir characterization, a geological framework, and then you now come to this portion which is within the dashed red rectangle. And a geological model needs to be built. It actually includes all available data, seismic surveys, well logs, core data, or mud logs, all that. The whole idea is to build a geological framework of the system. And once you have a geological model, which is typically called the static model, you can now use that for reservoir simulation. Now, because of the fine scale of the geological model, it's usually upscaled, and then from there you have what you call the flow model or the dynamic model, which in the case of the green reservoir, that's a reservoir which is yet to be produced, you can come up some forecasts of production under different uh, scenarios. For a brown reservoir where you have actual production data, you could tune your flow model to your production data through a process called history matching. Because you don't just want to build a model, you want to be able to use it for prediction purposes. So the idea is you tune the model, you tune simulated data using the production data to see if it can reproduce your production data. So it has to match your production data and your pressure data. Once you have a history match model, you can go ahead to use it for prediction purposes. Now, this is actually emphasizing on what we had on the previous slide. If I start now to the top left, you see input static data. I know in I think PGG451 you must have discussed this, where logs, geological concept, seismic data, core data, and this goes into what we refer to as a geologic model. You see, you have facies, you have petrophysics, real palm faults, and from this, the flow simulation model is built. That's the dynamic model is built. Now, a base case scenarios have been a base case run has been made here. You will see that you have different flow profiles here. This reminds one of our well test data, and you see, so you have an initial ensemble. This actually bringing in the concept of uncertainty. These are different possibilities. And here you see it says input dynamic data, and here your production and pressure data is actually brought into play. And then you see that the range over which you have this data is the band is reduced. And this is the process of history matching, which I mentioned. And going forward, you could now do some prescriptive analytics. Here you're looking at what your recovery factor is, looking at P90, P50, P10 forecast, and of course, your financiers will be very much interested in this. I see here it says accounting for uncertainty through repeatable models. And this tells us that for you to have robust simulation, you are not just looking at a deterministic case, you're also looking at probabilistic reservoir simulation. Now, so what reservoir simulation tools are available? Now, of course, almost practically all aspects of reservoir engineering are solved or addressed with reservoir simulators, ranging from farm recovery all the way to enhanced oil recoveries. So we have a number of commercial simulators. We have some which are free. Most of the free simulators are actually probably demos. And then you have open source simulators, actually the open source, which you could actually contribute to its development. Actually, it's open source, it's not open source commercial, it's open source. And but I want to reiterate again that you can't carry out reservoir simulation without having a robust reservoir model, reservoir geological model. Now, so some vendors have developed 3D modeling software, while some have developed reservoir simulators. Some companies like StormBG have platforms where you have seamless integration between your static modeling and your dynamic modeling. So typically the reservoir simulation software would have a preprocessor where it either imports the static model or it builds a very rough representation of the geologic model and brings in some data. Then the simulator itself that runs the cases, and the post-processor for graphing purposes and visualization and analytics, as the case may be. Now, this slide actually came from an assignment I gave some years back, and this captures static modeling software, dynamic modeling software, and integrated platforms. And this list is not exhaustive, but it does tells you that you have so many simulators in the market. Of course, the standard is the simulator by the software by Schlumberger, Petrel, Eclipse. You have Eclipse 100. This should be Eclipse 300. Actually, I'll correct that. Eclipse 100 and Eclipse 300, and then you have the Petrel EMP platform, and you have a number of them. See, you have Codes, Host, you have IMEX Gemstars by CMG, you have T Navigator, you have a number of them. Now, Impact is actually, I think it's for surrogate models using some artificial intelligence, and you have so many things. Yeah, the last two here, you have MATLAB, and you have MATLAB is actually an add-on tool. It's free, an add-on to MATLAB. And then OPM, the Open Initiative, is open source, which you can actually contribute to its development. Now, to the bottom right, you have the suit by PETEX, by Petroleum Experts. This is not actually a reservoir simulator. However, it has MBAL, which is for material balance modeling. And you see, material balance is actually zero-dimensional reservoir simulation. That's why I included it here. So, what can you look forward to? What should you expect? So, in our next lecture, we should talk about how simulator works, and then simulator keywords, and then probably do an overview of one or two software. So on the LMS, a link to a demo version of XXSim has been uploaded. I've also included an assignment. So I've reproduced it here just for our benefit. The assignment will be looking at the SP7 comparative project, which entails horizontal well simulation. So I'll encourage you to try your hands on that. We'll have our next session next week. Thank you very much.